The problem that I chose is from Chapter 3, Section 2, problem number 14. And it asks you to determine where Rolle's theorem can be applied to f on the closed interval, and if it can be applied, find all c values in an open interval such that f prime of c equals 0. And the function they gave you was f of x equals x minus 3 times x plus 1 squared, and the interval is negative 1, 3. So, you kind of have to apply Rolle's theorem like as a definition, and the definition says that it only applies if f is continuous on the closed interval, and this is true. This is a polynomial, and it's differentiable on the interval as well, which it is too because it's a polynomial, and so you prove that part of Rolle's theorem. And the next part is since that's true, and then f of a must equal f of b. And so, and a and b are both of the endpoints. So, first you do f of negative 1, and that ends up being 0, and then f of 3, when you plug that in, that also ends up being 0. So it's true, f of a equals f of b, so therefore Rolle's theorem applies, because all the points of the definition were true for this function. And so they asked you if it does apply, find the c values where the f prime of c equals 0, or where there's a relative minimum or maximum. And so you have to take the derivative of the original function, and I did that by using the power rule. And so x minus 3 times 2x plus 1 plus x plus 1 squared times 1, which is just x plus 1 squared. And you get this, and then I just factored it out, like added the like terms, or subtracted, and then you factor, so you get 3x squared minus 2x minus 5, and you factor that, and you get 3x minus 5 times x plus 1, and set it equal to 0, so the c values, where f prime of c equals 0 is at 5/3 and negative 1, and both of these points work because they're within the boundary that they set.